This is the brief on the dual nature of tensors. So we're diving into tensors, these things that are absolutely essential for describing fundamental physical properties, think gravity or stress. But it brings up this kind of tricky question, right? How do we describe something that's real when our measurements for it keep changing depending on our point of view? Okay, let's break down this dual nature. First, you've got the mathematical definition. For any quantity to actually be called a tensor, it has to pass this really strict verification test. This rule lays out exactly how the numbers, the components, have to change when you shift your perspective, your coordinate system. It's basically a check to prove the thing is truly independent of how you're measuring it. So that's the rule book. But second, and this is the key conceptual part, a tensor represents a physical object that exists totally independent of your coordinate system. Think of it like a vector, an arrow, just fixed in space. That arrow itself isn't changing one bit. That's the underlying reality. The numbers you use to describe it, though, they're just a representation, and they'll shift around every single time you change your perspective. And finally, this whole distinction is super important because that strict mathematical definition, it lets us do predictable arithmetic. You can add two tensors or multiply one by a scalar, and you are guaranteed that the result is also a tensor. It's proof that the math we're doing actually preserves the integrity of that constant, coordinate-independent reality. So really, tensors are these geometric tools where the component numbers change with your perspective, but the fundamental physical thing they represent is totally fixed and invariant.